Right now, every atom in your body is doing something impossible. Something so strange that the man who discovered it quit physics entirely and spent the rest of his life writing about biology instead. He could not live with what he had found. And what he found starts with a cat, a box, and a question you are about to get wrong. Here's the experiment. Picture a sealed steel box. Inside, one cat, one vial of poison, and one radioactive atom. The atom has a 50-50 chance of decaying in the next hour. If it decays, a sensor triggers a hammer that smashes the vial. Poison fills the box, the cat dies. If it does not decay, nothing happens. The cat lives. Simple enough. 50-50. Coin flip. The cat is either alive or dead, and you just do not know which one until you open the box. Except here's what quantum physics actually says, and this is where everything you thought you knew falls apart. According to the math, until the moment you open that box, the cat is not alive. The cat is not dead. The cat is alive and dead at the same time. Not as a metaphor, not as a way of saying we do not know, as an actual physical, mathematical state of reality. Think of it like this. Your crush. Right now, before you have ever asked them how they feel, they both like you and do not like you at the same time. Not because you don't know the answer, because the answer does not exist yet. It will not exist until you walk up and ask. The act of asking creates the answer. That is not a poetic way of describing it. That is what the physics says. Now here's where most people get the story completely backwards. You've probably been told that a physicist named Schrödinger came up with this experiment to teach people about quantum mechanics, to help them understand the strange behavior of atoms. That is the opposite of what happened. Schrödinger came up with the cat to blow up quantum mechanics. He looked at what the math was telling him. Tiny particles can exist in two states at once, and he thought, fine, let me show you all how insane that is. Let me connect that atom to a living, breathing cat and force you to say the cat is alive and dead at the same time. Let me make this theory so embarrassing that everyone drops it. It was not an explanation. It was a weapon, a logical grenade thrown at the feet of his own colleagues. And it backfired. Every experiment physicists ran confirmed exactly what Schrödinger was afraid of. Not roughly, not approximately, precisely. Particles genuinely exist in multiple states at the same time. He tried to prove the math was lying, and the math proved it was not. So what did Schrödinger do? He left, packed up, abandoned quantum physics, and spent the rest of his career writing about biology. He never came back. The man who built the bomb could not survive the explosion. But the thing he tried to destroy, it is still standing, and it's about to get much worse. So here's the trap. Here's where your brain is going wrong right now. You're thinking of the cat as either alive or dead, and you just don't have enough information to know which one it is. That feels reasonable. That feels like common sense. That is exactly how the world works at your size, in your kitchen, with your actual cat. But that's the trap. You're applying the rules of your world to a world that doesn't follow your rules. At the quantum level, either or doesn't exist. There's no hidden answer waiting behind the box lid. The cat is not secretly alive while you're not looking. The cat is not secretly dead. The answer genuinely does not exist until you create it by looking. The act of observation does not reveal reality. It creates it. And the trap is that every instinct you have rejects this. Your brain screams, things are what they are whether I'm watching or not. My coffee mug is on the table even when I leave the room. The moon exists even when nobody looks at it. Quantum mechanics says, at the smallest level, no, it does not. And it gets stranger because this is not just philosophy, it's measurable. And what the measurements show shouldn't be possible. Here's the experiment that keeps physicists up at night. Take a single electron and fire it at a wall with two tiny slits cut into it.
On the other side, a detector records where it lands. One dot, one position, like a bullet hitting a target. But fire thousands of electrons, one at a time, and the pattern they leave behind is not a random scatter. It's stripes, bands where thousands of electrons land, alternating with bands where zero land. That pattern is impossible unless each single electron passed through both slits at the same time. Not one then the other, both, simultaneously. This is not a thought experiment. This is a photograph. This pattern has been captured in labs around the world, and the evidence is not debated. What it means is what keeps people fighting. But here's where it stops being about particles in a lab and starts being about your body. The electrons inside your atoms don't sit still in one place like planets orbiting a sun. That image from your school textbook? Wrong. They exist as clouds, smeared across space, occupying many positions at once. And when two atoms come close enough to bond, their electron clouds merge. The electron belongs to both atoms at the same time. Think of it like this. Someone asks you, do you love this person or that person? And the honest answer is both, fully, simultaneously, not half and half, not switching back and forth, both, completely. That breaks the question itself. That is what electrons do to atoms. This is how every molecule in your body holds together. You're not made of solid things clicking into place. You're made of particles that refuse to choose, and that refusal is what keeps you alive. And here's the part that would have made Schrödinger throw his book across the room. Those merged, shared, both places at once electrons are the entire reason semiconductors work. They're the reason we can build transistors, millions of them, packed onto a chip smaller than your fingernail. And those chips power the phone or the computer you're using to watch this video, right now. The joke that Schrödinger built to demolish quantum mechanics, it's the foundation of the technology that runs modern civilization. He ran from the math, and the math built your entire world without him. So what's actually happening inside that box? Physicists have been fighting about this for almost a century, and the fight hasn't gotten quieter, it's gotten louder, because each answer demands you give up something you don't want to lose. If you accept the first answer, what physicists call the Copenhagen interpretation, then you accept that reality does not exist until you look at it. The cat is genuinely both alive and dead, and your observation is what forces the universe to pick one. That means you're not discovering the world, you're building it in real time, every time you open your eyes. Which means the question, what happens when nobody's watching, has no answer. Not because we don't know, because there is nothing there. If that disturbs you, the second answer is worse. The many worlds interpretation says the cat never has to choose because the universe splits. In one branch, you open the box and the cat is alive. In another, a different version of you opens the box and the cat is dead. Both outcomes happen. Both are real. And right now, versions of you are branching off with every quantum event in your body. You're not one person. You're an infinite tree of people who all think they're the only one. And if you reject both of those, the third answer, decoherence, sounds like the safe choice. It says the cat was never truly in superposition. Connect a quantum event to something as massive and chaotic as a living cat, and the quantum weirdness dissolves almost immediately. The cat was always either alive or dead, but here's the cost. It means there's a boundary somewhere between the atom and the cat where quantum rules stop and everyday rules take over, and nobody can tell you where that line is or why it exists. 3 answers. Each one takes something from you. None of them let you go back to the way you saw the world before you opened this box. Schrödinger wanted to prove the theory was broken. The theory proved reality was stranger than he could stomach. He ran. He left physics behind. And the impossible thing he ran from, it powers everything you see. Every screen, every signal, every byte of data that carried this video to your eyes. You're watching this on a machine built from quantum absurdity. Every pixel exists because electrons refuse to pick a side. And if that doesn't change how you look at the world around you tomorrow morning, then maybe you're not looking closely enough.